Alright, chemistry. This is the week 7 quiz review, and we're going to begin by doing some balancing. So I'm going to use the standard method first. Okay. And count the atoms on each side, 2 here and 1 here. Okay. I'm going to start with vanadium. You could have started with something else, but stay away from oxygen until the end. Okay, keep track of the oxygens because they appear in 2 different places. Okay, now we're going to go and we're going to balance chlorine. We got 1 here and 6 here, so we're going to put a 6 up here. Okay, so vanadium and chlorine are in balance. Hydrogen, we have 2 here and 6 on this side. So now we're going to multiply both sides by 3, put a coefficient there. Okay, and oxygen, now that changes the oxygen. You have 2 times 1 is 2, and 3 times 1 is 5, so now you have 5 oxygen. Okay, and that takes care of it. So it's going to be 1, 6, 2, 3. Right, the next one here. 2 here and 1 here makes 3 oxygen. Okay, we'll start with carbon. So now you have 3 times 2 is 6 plus 1 is 7 oxygen. Hydrogen, we have 2 here and 8 here, so we're going to have to put a 4 there. So that brings hydrogen into balance also. Alright, now you have 7 and 2 here. Alright, so again, this is why I should have done this. This is why you write your subscripts, just to show you here, up above at first, because you don't know if those are going to be your final, coefficients, your final coefficients, okay? So I got 2 oxygen on this side, 7 on this side, so I need to multiply this by 7 halves. That's going to be a 7 over 2, and 2 times 7 over 2 is going to give us 7. Okay, 2 times 7 over 2 gives you 7. So everything's in balance, but you can't have a fraction, so you multiply everything through by 2. This is a 1, so it's 2 times 1. Okay, this is 7 halves. Again, write it up above until you have the final. Okay, 2 times 3 and 2 times 4. Okay, and that gives you a 2, a 7, these cancel out, a 6, and an 8. Okay, we move on down to this problem, and you're going to treat the molecular ions as elements, so you're going to put them in parentheses. Again, it's optional to do that here. It's not here. Since it has a subscript of 2, you have to have a parenthesis there. Alright, so pick whatever you want. I'm going to go ahead and start with calcium. Alright, so now calcium's in balance. Chlorine, I'll go to that next. Over here there's 1, over here there's now 6. 2 times 3, so I'm going to put a 6 up here. Also changes sodium, makes that a 6. Okay. Now I have 2 sodium, 3 sodium here and 6 over here, 6 times 1. So I'm going to put a 2 here. So 2 times 3 is 6 for sodium. 2 times 1 is 2 for phosphate. And we have everything in balance. Okay, so you can go back and rewrite that as 3, 2, 1, and 6. Okay, if you'd like to use the box method, you're welcome to do that. You can come in for tutoring. Let me get this on screen, a little bit off screen there. Okay, there you go. Everything balances. Use the box method if you'd like. I'm not going to show it here. Okay, now we're moving on to a limiting reactants problem. So I'm giving you the reactants in grams. That means you have to convert to moles first, all right? So I'm going to go ahead, and I'm not going to ask you to convert the products back from moles into grams. So I'm just going to focus as far as molar mass on these two. So we're going to write two equivalencies here. Okay, so we're going to come over here. We need to figure out how many moles. So we have 5.82 grams of C2H4. I highly recommend that you label which one when you're doing reactants or empirical formulas. Okay, so here's the C2H4. I'm going to write it here. Okay, and that gives us 0.21 moles of C2H4. Next we do oxygen, O2. Okay, and that gives us 0.28 moles of O2. Okay, and now we're ready to start plugging in the numbers. Okay, this is all the C2H4 we have. This is all the O2 we have. So all the C2H4 goes in this all C2H4 row and under C2H4. So where C2H4 intersects, these are all in moles. Okay, and the all O2 0.28 goes in the all O2 row underneath O2. So just remember these two are automatic. Okay, I'll circle them like that. They're automatic. Now you ask, okay, if I want to combust this much C2H4, how much O2 do I need? You need 3 times as much O2 as C2H4. So if you multiply this by 3, you get this. Okay, and if I want to combust all the O2, I need 1/3 as much C2H4. Okay, and I'm going to divide that by 3. Okay, so I'm going to do this, divided by going in that direction, and this one was multiply by 3 going in that direction, divide by 3 going in that direction, and we're just going to round it to 0.9. Okay, so the way you check is at the end, this number is 3 times this number is 3 times this number, and this number is 3 times this number. Just remember that way to check. Okay, now we're ready to start answering questions. Okay, so we've done A and B. What is the limiting reactant? So first we got to go around and do we have this much or more? That's what at least means, at least this much. Do we have this much C2H4? The answer is yes. That's exactly how much we were given, so that's a yes. Do we have at least 0.63 moles? And the answer is no. We only have 0.28 moles. We don't have that, so that's going to be a no. Do we have this much O2 or more? The answer is yes. That's exactly what we have. And do we have this much C2H4 or more? Yes. Again, we have 0.21, so we have that much or more, so that's yes. Okay. Unless there's no limiting reactant, you're going to always end up with 3 yeses and a no. All right. So the limiting reactant is the column with the no in it. There's the no right there. That's limiting. Okay. So we've done that. So that's going to be, and actually write it out. Don't just circle it. So that's going to be O2 is limiting. How much of the non-limiting reactant is in excess? So first of all, which reaction is going to run? The reaction it's going to run is the one with 2 yeses. This one will not run to completion. You will not be able to combust all of the C2H4 because you don't have enough O2. So this one will run to completion. You have 0.28 moles of O2. In order to combust that all, you need 0.9 moles. You have that. So we're going to put a box around this one. which means we're going to use 0.09 moles of C2H4, but we were given 0.21, so the rest is going to be left over. Okay, so 0.12 moles C2H4 is in excess. Just write that right here. Don't forget to answer the question. Okay, it asks which is in excess and how much. Okay. All right, so now we've taken care of what excess, limiting, and which reaction is going to work. So now when you do this part over here, it doesn't matter what these compounds are, H2O, CO2, O2, it doesn't matter. All that matters is the coefficients, 1, 3, 2, 2. So simply find a relationship that's easy to do mathematically. So you're going to have twice as much CO2 as C2H4. You have this much in the reaction that runs. You're going to use this much C2H4 right here. So if you multiply that by 2, you're going to end up with 0.18 moles, okay, of CO2. And since these two coefficients are the same, 2 and 2, then this number has to be the same as that number. All right, and that takes care of how you do a limiting reactant problem. All right, now we're on to another limiting reactant. It's more complicated just because of the nature of the chemical reaction involved. So we're going to go ahead and do molar masses only of the reactants. I'm not going to ask you to convert back to grams over here. Just too much number crunching. So let me get started here. So we need the molar masses. And for H2SO4, we'll compute that. H2SO4, 3 there. Okay, so you're going to have this. Okay, sulfur off the periodic table. And oxygen, you have 12. 4 times 3. So that's 12. And it's oxygen, not O2. Okay, it's just you have 12 oxygen atoms, that's 16. Add these three numbers up. And we get 290.21. Okay, so now we take the reactants in grams and again keep track of which is which by labeling them. Now we'll go on setup for H2SO4. And now we'll calculate both of these, and I'm off screen. So that's what I did. I got the number from up top of the page and the molar mass that I computed over here. We're going to convert to moles. So we'll do those. Okay, and I did the calculations, made a slight correction here, 290.21. So when you do that, it's 0.25 moles of H2SO4 and it's 0.43 moles of Fe. Okay, now we're ready to go ahead and start the problem. So I'm going to bring it back up here and we're going to put the 0.43 moles of Fe in the box, all Fe under Fe here. So where the Fe's intersect, okay? All right, now we're going to take the 0.25 moles of H2SO4 and put it in the all H2SO4. If we reacted all of that, okay, moles of all underneath H2SO4. Now we're ready to figure out, okay, we have much H2SO4 as Fe. So that just makes the math a little more complicated. So you're going to multiply by 3 and divide by 2, and you're going to get roughly 0.65. Okay, so in this direction, you're multiplying by 3 halves. Multiply by 3, divide by 2. Going in this direction, you're going to multiply by 2/3. You're going to end up with 2/3 as much Fe as you have H2SO4. So we multiply that by 2/3, all right? And what we get for that is 0.17 roughly. 1718 or 5, okay? All right, now we go around and do the yes, 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 no. Okay, so 0.43, do we have at least that much? Yes, we have exactly that much down here, so that's a yes. And let's just skip over to this one. Do we have at least 0.25 moles of H2SO4? And the answer is yes. So we have exactly this much and exactly this much. So these two boxes are automatics, okay? So that's a yes. Now we're going to go over here. In order to combust all of the Fe, we need this much H2SO4. Do we have that much or more? Well, no. We only have 0.25. We only have 0.25 down here, okay? Or the shortcut way to do it is just look down here. This is how much you actually have. Do you have this much or more? No, you don't have this much. So that's going to be a no. Okay. And to combust all the H2SO4, we need 0.7 moles of Fe. Do we have that much or more? Yes, just look up here. Yes, we have more than 0.17. So that's a yes. So 3 yeses and a no. So this is the no. Okay. So now we're going to go down and answer the questions. So we did this. Okay, what's the limiting reactant? It's the column with the no in it. I'm going to draw a box around it, but I still want you to write out the words, okay? So the limiting reactant is H2SO4 3. Which reaction runs all the way to completion? It's the one with the 2 yeses. That's the bottom one. So you can just put a big box around that. That one will run to completion, okay? Okay, next up, which reaction runs to completion? It's the one with the 2 yeses in it. Look at it this way now, in rows. Yes, yes, this one will. So it's the all H2SO4 right here. Okay. Okay, so if this is limiting, I'll write it right here. Then this is excess over here. And so this reaction is going to run. You're going to require 0.7 moles of Fe. You were given 0.43 moles, so the difference between those two is how much in excess, okay? Okay, and that's how you would write the answers. 0.26 moles Fe in excess, okay? All right, now how many moles of these over here? So you put a line through the reaction that's not going to run. You're not going to do this one. You're going to do the one that actually runs, okay? So what it's saying is, let's start with H2. It's easier. You need 3 moles of this, 3 moles of this. So whatever this number is going to be. So 0.25. Okay. And this one, you can say that you need 1/3 as much of this as this, because it's a 1/3.